Hello there, it's Jay here from Jay's Vintage Junk, and today we're having a quick look at this. Now, first of all, I'll have to apologise. I did start recording this, and I thought I'd started recording it anyway, and I've actually opened the case already, and then I realised that I hadn't actually pressed record. But we haven't actually gone into the repair yet. I've literally just managed to get the case open, which, if anyone knows on these old power supplies, is a bit of a pain because they're actually heat sealed together. These were never really intended, I don't think, to be repaired. I think when they failed, you just threw them away and ordered another. Well, obviously nowadays we can't do that. Basically, this is the power supply for an early 90's Apple laptop. It's the supply for a Macintosh PowerBook Duo. And I was told that apparently it went off with a bang. It went off with a pop and a bang. And I thought we'd just see if there's anything I can do with it. This came with the Spectrum that I've just done the little repair and service on. Just as a little of an extra, or would I mind having a look at it? And I like messing with this old stuff, so I said, yeah, no problem. I said, we'll get inside it. I mean, I've already spotted what the main issue with it is, and it's quite a common one that we all know and love. If we get the top off, and actually get the board out, there's some little standoffs there that hold the board in. I'll put all those little pieces. I think the biggest problem with this actually is going to be trying to reassemble the case. I don't think the repair of the power supply itself is going to be that much of an issue. What I can spot, we've got a Rifa cap there that's gone bang. Now I'm hoping that actually is the only fault that this thing's got. We've got a Rifa X2 capacitor there, and I can see it's blown. So like I say, I think that's probably what the issue with this thing is. Unfortunately, construction-wise, I mean, it's very nicely made, this power supply. It's an Aztec. Yeah. I don't know if you can make that out on there, but it says 1991 Aztec Custom Power. Now, I know in earlier times that Apple bought their power supplies from Aztecs. I know the Apple IIs, the power supply in an Apple II is made by Aztec. I mean, Aztec were like quite a good brand power supply manufacturer. I don't even know where Aztec is still going today, but I know back in the day, they weren't cheap rubbish from Aztec. They did make nice, decent power supplies, really. What we're going to have to do, though, to even get to the back of the board, so we can whip that Rifa cap out, we're going to have to desolder these points here, take this back shield off, and then we can get this isolating cardboard off. I mean, design-wise, it's very well shielded. I wonder if that was a particular stipulation from Apple, that they wanted, decent shielding on it. Let me just see if I can find my... I think we could probably do this with the solder sucker. I don't think we actually need the desoldering station for... there it is. So I don't think we need the desoldering station to get these out. I think we should just be able to do it with the manual desoldering pump. And get that cocked and ready to go. You might just want to add a little bit of fresh solder, though, just to help this old solder flow, so we can get these out easy enough. So let's just try a little bit of fresh solder. I've got most of it out. I think that's the first one free. Give it a little whittle. Lift that one up. Now these points, let's have a look how they've done these points, because that was just a piece of wire that had been poked through, bent over and soldered We'll add a little bit of fresh to these and we'll have a go see what we've got here. That's released. This might be easy enough to do. That's going to need another go. And hopefully we can get that off now. Let's give that a try. So we'll get something under there. There we are. There we are. So that's the ground, the shielding off. Let us lift off this, this plastic sheeting. There we go. Obviously that'll have to go back on. I think that capacitor really did spew its guts. It don't look too bad under there. Let's have a look at taking. That's the culprit right there. That's a big capacitor as well. 15. Ah. Well, have we seen this? I'll zoom you in. I don't think this is a normal Rifa capacitor. It's certainly not like one I've seen before. We've got 0.15 UF X2, and then we've got 2 times 47 PF Y type. So is this like a multi-capacitor all in one? Can't say I've ever come across that before. We'll get it out of the board, and we'll have a look at it. We'll have a look at it out of the board. I was just expecting, you know, when I first saw it, oh, it's just a normal Rifa across the mains cap. I'm not so sure now. Is that a leg from it? Right, let's see if we can get this out. Try a little bit of fresh solder on that. These connections don't feel quite as nice to take off as that shielding was. Ah, that's gone now. Let's just give this one another go. Let's see if that'll come out. We may have to get the desoldering station on it. In fact, let's try. Let's try heating the pads up and see. See, I think that centre one there is actually a third connection. Oh, right, that broke free. That side's out. Let's see if this side will do the same. I think the capacitor's going to start breaking up. Let's see if we can get something under there and just give it a little bit of leverage. Obviously we don't want to strain it too much, but let's see what we can do. Yes, this is a very strange capacitor. Trust Apple. There we go, that's out. And yeah, we seem to have a combination capacitor here, and that went straight to ground. So we've got a centre point to ground. Let me have a look at hopefully we can figure out how this thing's wired, and you can see where it's actually blown apart. Let's have a see if we can put this together and see how this thing's meant to be wired. Right, so we've got a ground. Unfortunately, it's broken off right through where the little diagram is. Aha, right, okay. Let me just get a pen and a piece of paper and I'll just sketch out what I've just, because I don't think I'll be able to pick that up on the camera. But let me just see if I can find a scrap of paper and I'll just quickly sketch out what we've got on there. I'll put a piece of paper down there. I've got a pen. Yes, I have. Right. So what we've got is we've got ground in the centre there. So that's earth there. Then we've got one capacitor there. Then we've got another capacitor there. Then we've got the third capacitor there. So we've got a 47,000 picofarad there, 47,000 p. We've got a 47,000 picofarad there, and we've got a 0.15 UF there. Then we've got our basically we've got our live on that side, we've got our neutral on that side, and we've got our earth down there. So essentially we've got three capacitors inside that. We've got we've got an X2 type capacitor there, and then we've got a Y type capacitor there and a Y type capacitor there. Now I know for a fact I've definitely got something we can replace that X2 for there. What I don't know yet, I'm going to have to look through all my stocks, or if we've got two Y type capacitors for there. Now these are safety critical parts. I can't just put any old capacitor in here. That needs to be an X2 capacitor. Those need to be Y type capacitors. So basically what we need to do, I don't honestly think you can get one of those anymore. If you can, it's probably going to be a new old stock Rifa one like this, and it'll probably, if it don't, it'll either do the straight thing as soon as you power it up, or you know, it's going to fail sooner rather than later, because these things fail due to old age, not due to use. The plastic starts failing on them, moisture gets in there, and this is what happens, they go bang. I mean, if you're into vintage electronics, you know how many of these fail regularly now. Number of computers I've fired up that haven't been used for a very long time where this has gone pop. But that's just been a normal X2 style Rifa brand capacitor. I've never ever come across one of these where it's got three capacitors in one unit. That's quite interesting, that. I'll have to see if we ever come across. In fact, if anyone else does a lot of this, have you come across these before? Because this is the first for me. I mean, I've come across circuits similar to this, but just using separate capacitors. I've never come across that where you've got the X2 and two Y capacitors all mounted up in one little capacitor like that. I've got something very similar, actually, thinking about it. My Bosch drill. That uses something similar. I'm not sure if they're the same capacitors, but that uses something very similar where it's got a third connection off, and it's got like 3 capacitors all mounted into one unit, but I don't think it's quite the same as this. It's certainly not going to be the same values. I'm going to just pause the camera and I'm going to have a quick flick through all the X and Y rated capacitors I've got, and I'll see what I can come up with that we can possibly replace this with, and then we can see about seeing if we can actually get this power supply to work again. So back in a sec. Okay, I'm back and I've had a rummage, and what I've come up with, I've got a nice X2 there which will replace that capacitor there, and I've got a couple of Y-type capacitors which will replace those 2 capacitors there. But obviously, like I said, all that was built into that one unit, so we're going to have to do a little bit of jiggery pokery here, really, to get all this to actually fit and work in the space that we've got down there. What I'm going to try and do is basically, we're going to try and tie those 2 legs like that together and make that as our center connection, our ground connection. So we'll have to extend that on a little bit with a piece of wire, and that can come down to do it for our ground connection. Then we'll have to connect that point to those 2 points there and make them our other 2 connections to come down, and basically just make that circuit using these discrete capacitors. I think this is probably going to be the best way of tackling this. I mean, we don't know if any other damage has actually been done to the power supply. So what I want to do, I'm going to try it. And these things, technically, it should run without these capacitors in circuit, but we better have them in there. Like I said, it is to do with the part of the safety. I don't know if it's all safety or it's safety and interference suppression. Let's try putting those. And crimp that together with them. Try bending that back around there a few times. We want to make a really good mechanical connection. And bring that out. We need to solder that center point there. Okay, that's the first part, and then we've got to figure out how we're going to mount that on there as well. Now, fortunately, there's nothing for anything to short to on the PCB. So, providing we get this so we can have it standing slightly off the board, we should get away with it. But we need enough room that this is actually going to fit flush and us be able to get the case back on. So this is quite a tricky. Form a little like I just did. I'm going to form a little can solder that in place. I do hope there's going to be enough room for this to actually work. So we can get that. I want that as far down there as it'll go. There we go. So we've got that soldered on there like that. And we should be able to cut off, yeah, so it's nice and flat. Let's try and do the same on that leg there. So I'll just form a little loop in the end of the forming a little loop in the end of the wire. And put that over the end of the wire like that. We'll try giving that a quick squeeze, see if we can get it clamped onto the wire. So we've got a decent enough mechanical connection before we even attempt to solder it in place as well. We want it as far down on there as we can get it. So we're going to want to cut the excess off so it's nice and flat, this thing. Otherwise we're not, well, even if we can get it in there, we're not going to be able to get the case to go back together. We'll solder that in place like that. So we can get that a bit flatter down, but I think that's probably going to be about it. A little bit. There we go. Bend that out. We can cut the excess that leg off now. There we go. So that's the two legs extended. We'll take this, and what we're going to want to do, we're going to want that about there. In fact, we need to flatten them legs in as flat as we can get them. So we'll bend that in like that. We'll bend like that in. Basically what we want is we want our pins to line up with the pins on the old one. So that's looking about right. I want that about there. In fact, yeah, about there should do. So we bend that leg round so it picks up the leg of the blue. I'll show you this once I've actually done it. It's a little bit hard to form this, and I have to kind of like hold it, or else it's all going to spring apart. Just while I get these legs bent in place. Okay. Kind of like that. Let me just get a pair of pliers on that to tighten it up. There we go. Now let me solder these in place so they're not going to move. One there. One there, like that. And basically, we have to manipulate these legs slightly to get them in the right place. Let's try that now. Bend that in, that in. I think that'll work. So essentially we've made a new one of those just out of discrete components. So that is basically exactly the same, you know, that is exactly the same electronically as that. But hopefully we can now get this to fit in the fit this into the power supply. There we are. I think that doesn't touch anything it shouldn't touch. You need the centre pin sticking out because that's actually what the shielding connects to, because that's our ground. and the other two just need soldering in place, because those will go across the one goes from live to neutral, and like I said, and then you've got the two Y rated capacitors that go from each side, one from neutral, one from live, both to ground, both to earth. So we'll solder those two into position. One there, one there, like that. And get them cut off. I could do with my other snips. Where are my other snips? Ah, there they are. These are better. Oh, I was using them. That's it. There we go. So that's that sorted. That is that replaced. Now I can't see a fuse or anything on that side. We'll check that resistor there just to make sure that resistor's got continuity. And then we may see whether this power supply is actually going to produce some voltages. So I was hopeful that that's what the only thing was. Like I said, you got a bang coming out of it. Right. Oops. Set that to about there. No. Because sometimes they use a resistor like this, a bit like a fuse. Nope, that's fine. So we're probably going to be okay to actually do a test on this and make sure that was the only. Oh, I just need to solder that down slightly. There we go. And let's just figure out which one of these connections is our ground point. Because we've got two, I'm not 100% sure, but I presume this could have slid into a dock or something, because as well as having, a normal power style connector on the end there, it also has these. So like I said, I have a feeling that this was designed to connect into the back of a dock, and those would marry up. Right, let's have a look here. So we'll go to the heatsink. That should be a good ground. Right, so it's looking like that's our ground there. And then we've got 3 voltages coming off it. In fact, we can just double check that. We've got a capacitor there, and the negative side of the capacitor is that side there, and that goes exactly to the same trace that it was just on. So we can hook our probe on there, and we know we're on ground. Just be a bit careful that doesn't touch the next electrical contact along. And all we need now is an IEC lead. We can power this thing up, and we can just do some voltage checks. I'll just see if I can find a IEC lead, and we'll be back in a sec. Okay, I found an IEC lead, and I've just got this roughly connected up. We found where the ground was. I've got it connected up. I hope this should be the right wire. Let's just switch on and let's see what we get on the tester here. We're getting 24.9 volts off that connection there. Like I said, that's offload though. The problem is I don't actually know what this is meant to produce. I'll have to have a look at the specs for the actual laptop. The problem is that Apple don't give you really any information. Like, so you haven't got a chance in hell of finding a circuit diagram for this power supply. I'm guessing that must be about right. I mean, if it's got, yeah, because if it's got, the laptop will have a DC to DC converter, and then it'll derive all its lower voltages from that higher voltage. There might even be a higher voltage still for a charging voltage for the battery, although probably 24 volts is probably enough for that. Let's have a quick look. What's on this pin here? There's nothing on that pin at all. I'm switching the right one, won't I? Yeah, there's nothing on that pin. I wonder if those are sense pins or something like that. But this one, yeah, I've got a good 24 volts there. We'll switch off and just watch that fade away, because obviously I'm going to be handling this board in a second, and we want to make sure that there's no power on it while I'm actually handling it. Right, we'll just disconnect that. I just want to just check on the main smoothing capacitor whether it's got any charge left in it before I actually start playing about with this thing. Like I said, because you've obviously seen we've just had mains on it, even though it's disconnected from the mains now. There is a potential for basically that capacitor there to store quite a nasty charge. I mean, it's a 400 volt capacitor at 68 UF, so it's got, it's got quite a reserve in it. Let's just make sure that which is the neg side. We'll just check with the meter, just make sure that that charge has bled away. Most modern power supplies, most switching power supplies, actually have a bleed resistor across the high voltage capacitors to actually dissipate that charge. But you're always better just checking. So we just watch on the meter there while I just go across these two pins. And yeah, what tiny little was there has literally just dissipated to absolutely nothing as I watched. So that's perfectly safe now. I'm quite happy to actually touch this now. You always want to be a little bit careful because of what it is. But we'll have a go at reassembling this power supply now. I think it literally was just that capacitor that had let go, which had killed this thing. And said, what we've done there is basically we've just made that out of single capacitors. So we've got exactly the same protection that we had before we started. Like I said, all we've done is we've made it out of 3 individual capacitors instead of it being that one monolithic 3 capacitor lot. Right, let's try and put all the put all this back together. Yeah, I think that's going to go in okay. I must snip that up. I think I must have caught the plastic here with my soldering iron. Just melted that little bit. Unfortunately, there's nothing conductive anywhere around there. I mean, that is one of our solder points anyway. So let's have a look at putting the metalwork back on. We've got to get that pin that we made go through that hole. To make sure that this is on the right side of that, because that's our insulator. This might be a little bit of fiddling and faffing about to get all this to go together. Let's see. Let's get that there. Right, let's bend that over a little bit so it doesn't come back out again. Make sure that that's on the right side. Make sure we can get that hole through there. Make sure we can get that. There we go. That's it. Bend that flat. Push that down, so we need to solder that point there, and solder back that point there. Let's get that soldered down first, and then we're not worrying about it. We'll solder down there. hold that for a sec while that goes off. We can solder this point into position. Like that. And then we've got to solder this point here down as well. Well, that's gone through nicely, that's gone straight through. So we'll solder that down. There we go. And now I've got the fun part of trying to get this power supply back together. And so this is going to be the tricky bit, because these power supplies were never ever designed to actually come apart. In fact, you have to be quite ingenious to actually get the cases from these things apart. And we know it goes into the case that way round, and we've got there's little cutouts in the plastic that the board basically locks into on one side, and then we have these little things here. I'm not actually sure if that's anything to do with this or not, but we have these little things here that we need to go into this side, which lock the board down into place. As well as that, we also have to get all them contacts back into there in the right place. Then we've got the latching mechanism for the cable retainer that we need to see if we can get that all back into place. It's not particularly easy, this bit. The electrical repair of the power supply was actually easier than the reassembly aspect of it. And that one goes on there like that, I think. Or does it go that way around? Might go that way around. Ah, yeah, that goes in there like that. I think one of them goes in each one of these little one in there like that. Hopefully you can see what I'm doing. They are really fiddly little plastic retainers that clip into a little groove on the side of the PCB like that. You can see that there. Let me zoom you in so you can see the horrible little things. There, as you can see, there's one there, and there's one on the other side. And then there's basically in the case itself, there's little notches that those sit into and lock the PCB into place. So let's see if this is going to work now. I think we have to get that side in first. And then push it down and lock the other side in. There we are. Let's sit that down. Make sure that these little contacts sit in. They've basically got a little slot for each one that they have to slide into. Horrible fiddly little thing. Ah, okay. Push that down. Make sure that those are all in the correct spots. And I think we've actually got the board back into place. Now this goes, I've got it the wrong way around. Right, spin it round, and then we've got to deal with these. Now these, which way around do they go? Is it that way around? I think so. And these are part of the hinge mechanism for the cable retainer. So those have to fit in, and there's some slots on the top that those also fit into. and then we have the cable retainer bits themselves, which I think, because these are meant to pop out like that. Have I got them in the wrong way around? Do they go in that way around? Ah, I had them in the wrong way around. They go in like that. These fit like that. Yeah. Oh, and that cable has, oops, that cable there has to come out there. I thought it came, damn, so I've got to take that out, and then finagle this wire. Go in there like that. I think that cable runs down the back of where that, like that, then into there like that. I think that's how it went. So that's in there like that. That sits behind there. That sits in there. I think that's right. I hope that's right. It's unfortunate that when it came apart, it did come apart with a little bit of a pop. These things are basically welded together when they're made, and the cases were never ever designed to be opened. It takes a lot of bending and prying to actually get these cases open without doing major damage to them. What I might do is try and get it together that far and then get them pieces in at the last second. All that side's gone together, so it's just a case of getting these. We're nearly there, I think. That's got enough room to go in there, yeah. So what's stopping that from? That's free. There's just something on this side that's preventing that from going in there. Tell you what folks, I'll just pause the video and I'll be back as soon as I've sorted this out. Okay, I managed to get it together. Please ignore the tape. The tape is literally there because that was a real faff to get together. I had to literally squeeze it together, push in the little cable retaining tabs there, and then run some glue in. I've glued it back all around the seams, and I didn't want to let go of it to switch the camera back on. It was such a faff to get back together, so I literally held it and then I wrapped a couple of bands of tape round each side just to hold it. So hopefully once that's dried, like I said, it should hold the case back together just as well as it was originally. The only thing I'm slightly concerned of, and I won't know until I get get the tape off is whether them two cable retainers are going to work properly, because that's the only thing. You know, these things were never designed to be opened. Obviously you've got to force them open to get in them. They never go back perfectly, but if we can make it from a non-functioning power supply back into a fully functioning power supply, I mean, it's mission accomplished. And it's not going to look terrible. Like I said, once the tape's been removed, it's not going to look bashed about or anything. It's just, I've got my doubts for how good them two clips for the cable retainer are going to be. But anyway, let's get the IEC, and we'll just see whether it's going to actually function for us. We'll plug in, so we can get get power off there, and we'll see if we can get power off here. But it's going to be very, very tricky. It's a weird Apple connector that which I've not come across before. We'll switch on. In fact, where's my where is my multitester? Let's switch on. And I'm hoping that the outer on this is going to be ground. And if we touch, you see, I'm not sure which pin on here is what. I'll see if I can get in there and see. Now, I'm not sure what there's connections in here that I can't even get to, so I don't actually know on that connection. Unfortunately, it's just going to have to try it on the Mac, I think. I can't honestly get to all the pinouts on there. It's such a weird connector, but we can definitely see that we've got our on these little pinouts here. We can see that we've got our the voltages that we should have, I think. Yeah, there's our 24 volts. I'm guessing that is the main voltage. I'm guessing the other two pins might be to do with battery charging. There might be sense pins for the controller in there. It's a reasonably well-made power supply. Like I say, it is an Aztec power supply, or at least designed by Aztec. It's Aztec custom power supply. Most interesting. Like I said, I've never been in one of them before. They've definitely designed it so it's not intended to be repaired. It's intended that you literally, if it failed in the day, I suppose you just contact Apple and buy a new one off Apple, or if it was still in warranty, I presume Apple would just send you one. That is most interesting. I've repaired many a power supply over the years, and I can't say I've ever come across a Rifa brand multi-capacitor like that before. But these might be something to look out for. I don't know how many other Apple products have got them in, but it's certainly something a little bit different to the standard Rifa X2s that we find in a lot of equipment. So we've got a Rifa X2 and two Rifa 47,000 PF, sorry, 4,700 PF Class Y capacitors, all in the same little thing. Anyway, I'm going to leave it there for now. Like I said, it was just meant to be a quick little video. This I weren't expecting to find something like that, to be honest. I will let the glue dry on that. I can get the tape off it, and it can go back to its owner, and you can give it a try. I'm just hoping that the laptop he actually uses, he's got for this, is actually still in working order as well, being it's going to be an early 90s Apple laptop, and we know how the capacitors in early 90s Apple equipment likes to behave. But it looks like we've solved the problem with the power supply anyway, so all we can do is give it him back, and he can try it on the laptop and see if it's actually going to work. So like I say, I hope you enjoyed that little repair. So thanks for watching, and goodbye.